what do we know about Fourier series? Suppose we have given two L periodic function f of x for the fundamental domain minus L less than or equal to x less than or equal to L for all x belongs to R. Then what is the Fourier series representation of this function? Is this f of x equal to a0 by 2 plus summation n is from 1 to infinity an cos n pi x upon L plus bn sine n pi x upon L. You know this thing, where what is a0? A0 is 1 upon L integration over minus L to L f of x dx. An is 1 upon L integration minus L to L f of x into cos n pi x upon L dx. And what is bn? Is 1 upon L integration minus L to L f of x into sine n pi x upon L dx. Here a0, an and bn are called the Fourier coefficients, and this relation f of x equal to a0 by 2 plus summation, this is called the Fourier series of the function f of x. Clear? You know this thing. Now, before starting the Fourier series for even or odd function, let us discuss one formula which you learnt in 12th standard. What is the integration of minus a to a f of x dx when f of x is even function and odd function? So this is equal to 2 times integration 0 to a f of x dx when f of x is even, and this is equal to 0 when f of x is odd. Now, do you know what is even function? What is even function? When we can say that f of x is same as f of minus x, then this is called even function. For example, f of x is x square, cos x, etc. These are the examples of even functions. Which are the odd functions? When we can say that f of x is equal to minus of f of minus x. For example, x, x cube, sine x. These are few examples of the odd functions. So when f of x is even function, integration over minus a to f of x dx can be represented by this. And when f of x is odd function, this integration has value 0. Now, suppose we have given dual periodic f of x over the fundamental domain minus L to L. Now, two kind of cases we have. The case number 1 is suppose f of x is even. Case number 1 is suppose f of x is even, and the other case is this: when f of x is odd. Now if you apply this relation, right, to a0, an and bn, right, then in this case when f of x is even, what we can say about a0? A0 can be represented by, actually A0 is this, 1 upon L minus L to L f of x dx. F of x is even, so we write in this way. Clear? So this is equal to 2 upon L integration 0 to L f of x dx. What is an in this case? Look at an. An is f of x into cos nx. You know that f of x is even, cos nx is also even, so the product of two even function is even. So f of x into cos n pi x upon L is even function. So for the even function the relation is this. So we can rewrite an as 2 upon L integration 0 to L f of x into cos n pi x upon L dx. And what is bn? Let us discuss. Bn is this, f of x into sin nx. In our case f of x is even, sin x we know that this is odd function, so the product of even into odd function is odd, right? And when f of x is odd function, we can say that this relation is 0, and so this integral becomes 0, and therefore bn is equal to 0, right? In this case when f of x is odd, so when f of x is odd, obviously this integration is 0. That means we can say that a0 is equal to 0 because f of x is odd. So here a0 is equal to 0. What is an? Look at here, an, f of x is odd function, cos n pi x upon L is even function, so odd into even is odd function, right? And when function is odd, the integral is 0, and therefore an is also 0. What is bn? See, f of x is odd, sine is odd function, product of two odd function is even, odd into odd is even. Can you understand why odd into odd is even? So suppose I have given two functions, f of x and g of x. Both are odd functions. What does it mean? F of x is equal to f of minus x and g of x is equal to g of minus x, right? Now suppose I define new function hx, which is product of these two f of x into g of x. Then what can you say about h of minus x? What is h of minus x? This is f of minus x into g of minus x. F of minus x is minus f of x, and this is minus g of x, because these are odd functions. So this is equal to f of x into g of x, which is hx. So h of minus x is equal to hx, right? So the product of two odd function is even. So when the function is even, we have the case 2 times integral 0 to a. So here bn becomes 2 upon L integration over 0 to L f of x into sine n pi x upon L dx. Then what is the Fourier series in both the case? In this case, f of x is equal to a0 by 2 plus summation n is from 1 to infinity an into cos n pi x upon L plus bn into sin n pi x upon L, but since bn is 0, this term becomes 0, right? Because in this case bn is equal to 0. Now in this case a0 is 0 and ans are 0, so a0 by 2 becomes 0 and an cos n pi x upon L becomes 0, and so in this case the Fourier series is f of x is equal to only summation n is from 1 to infinity bn into sine n pi x upon L. Okay, so this is simple. When we have given function in general, then what is the Fourier series and which are the Fourier coefficients. Now if we know the relation of that particular function, suppose it is e1, then what is the Fourier series and which are the coefficients. Suppose f of x is odd, then what is the Fourier series and which are the coefficients. And the examples of the Fourier series for even function and odd functions are not difficult. Now let us go ahead. Half range Fourier cosine series and half range Fourier sine series. So what is our purpose in this half range Fourier sine series and cosine series? If you look at the formula of this Fourier series, then this Fourier series contains the term which has cos function and the term which has sine function, right? So the series contains both cos and sine. Now the half range cosine series half range Fourier cosine series is the series which contains only the term of cos. In the sine series, the terms which contains only sine, right? Here the requirement is the functions are 2L periodic over minus L to L. Now half range is, so the total length of this fundamental domain is 2L. In place of that, suppose we have given the functions f of x on the half interval 0 less than or equal to x less than or equal to L, and we are assuming that these are 2L periodic functions. So what is missing here? Actually the fundamental domain should have length 2L. Here we have given the domain has only length L. That means we need to extend this for more L unit length, right? So let us discuss it with the examples, so the idea will be clear more. Okay, now suppose we have given this function f of x. This is my function f of x, say for 0 to L. This is f of x. Now I have to extend this function for minus L to L. Now two possibilities I have. This is the function f of x over 0 to L. So over minus L to L, and here over minus L to L. So I need to extend this function for minus L to 0 and for minus L to 0. So two possibilities I have. Either I can construct the even function, or I can construct the odd function. Right. So this is our assumption, that suppose f of x is even. Here our assumption is suppose f of x is odd. These are the only two possibilities we have. So in this case, f of x now is defined on minus L to L, which is even function. Here f of x defined on minus L to L, which is odd function. So this is the case for even f of x, and this is the case for odd f of x. And these are the 12 periodic functions. So the same portion, this portion will be repeated for to left hand side and right hand side, and this portion will be repeated to left side and right side. Clear? So what is the Fourier series in these two cases? When f of x is even, you know that what is the Fourier series. F of x is equal to a0 by 2 plus summation n is 1 to infinity n cos n pi x upon L. And in this case, f of x is equal to summation n is 1 to infinity bn sine n pi x upon L, because this is the case for odd function and this is the case for even function, where what is our a0? A0 is this. For even function, you know that this is defined for 0 to L f of x dx. And what is an? N is 2 upon L integration 0 to L f of x into sine n pi x upon L dx. Here we have bn, which is 2 upon L integration 0 to L f of x into sine n pi x upon L dx. Clear? This formula f of x equal to a0 by 2, this one. This is called half range Fourier cosine series. And this one is called half range Fourier sine series. Okay, now if you compare half range Fourier cosine series with the case of even function, then they are same. And the case of odd function and the half range Fourier sine series, they are same. Okay, now let us discuss with one example. So suppose I have given one function. The exercise is find Fourier sine series for f of x is equal to, let us take m into x when 0 less than x less than pi by 2, and m into x minus pi when pi by 2 less than x less than pi. What is our requirement? I want to find Fourier sine series. And you know what is the formula for Fourier sine series? F of x is equal to, and where Bn is equal to. So let us note down this. What we want, f of x is equal to summation n is from 1 to infinity Bn sine n pi x upon L, where what is Bn? Bn is equal to 2 upon L integration 0 to L f of x into into sine n pi x upon L dx. But here what is L? We have given the domain 0 to pi. That means L equal to pi, right? So here what will be our f of x? When you substitute L is equal to pi here, we can cancel out this pi and pi, right? And so the remaining quantity will be nx only. So this is summation n is equal to 1 to infinity Bn into sine nx, where what is Bn? 2 upon L is equal to pi integration 0 to pi f of x into sine nx dx. So now we need to evaluate only this Bn, and that we substitute here. That's all. Only we need to do this thing. So now let us evaluate Bn. What is Bn? 2 upon pi integration 0 to pi. Now see, this domain 0 to pi is divided into two parts, 0 to pi by 2 and pi by 2 to pi. So we have to divide this integral into two parts, 0 to pi by 2 and pi by 2 to pi. When it is 0 to pi by 2, my function is mx, so that is my f of x, right? So I write mx into sine nx dx. When the domain is pi by 2 to pi, then my f of x is m into x minus pi, which I write here, and so it is m into x minus pi into sine nx dx. So now we only need to integrate mx into sine nx and m into x minus pi into sine nx. So let us proceed further. So this is 2 upon pi. How do you integrate this? Suppose this is function u, this is function v. Then we use the general rule of integration by parts. You know what is that rule? The rule is u remains as it is and we integrate v. So what is the integration of sine nx? The integration of sine nx is minus cos nx upon n. I write opposite sign. Now we do derivative of this. So what is the derivative of that with respect to x? It is m, and we do integration of this bracket again, right? So the integration is minus sine nx upon n square. For the limit 0 to pi by 2. This is the integration of this integration. Now let us integrate this quantity. So again we do the same thing. Suppose this is our u and this is our v. Then what we do? We simply integrate u as it is. So m into x minus pi will remain same. Integration of this quantity, that you know, the integration is minus cos nx upon n, opposite sign, derivative of this bracket. What is the derivative of the bracket? Is just m. Derivative of x is 1, derivative of pi is 0, so it is 1, into integration of this bracket. What is that integration? Minus sine nx upon n square over the limit pi by 2 to pi, and in between we have plus sign. Close the main bracket. Now let us substitute the values. So this is equal to 2 upon pi into, now see, upper limit when x is equal to pi by 2, right? This is the minus sign, m into x equal to pi by 2, so that I am writing here minus m pi by 2, and this n multiply by cos n pi by 2. Then here minus minus plus, so we have plus m divided by n square into sine n pi by 2. This is the value for upper limit when x is equal to pi by 2. Now we substitute x is equal to 0, right? Minus sign for the lower limit. I write the values always in the bracket for the lower limit, right? Okay, so when x is equal to 0, m into 0, which is 0, so 0 into this is 0, so the answer of this is 0. Here when x is equal to 0, this will be sine 0, and you know what is sine 0 is 0, so m into 0 will be 0, right? So here the answer is 0 plus 0. Now for this particular quantity plus, let us substitute x is equal to pi. So pi minus pi becomes 0. So this is the first term is 0. Now here we have minus minus plus, x is equal to pi, then this is sine n pi plus sine n pi divided by n square. Now minus sign for lower limit, and let us substitute the lower limit. X is equal to pi by 2. So when x is equal to pi by 2, this is pi by 2 minus pi. What is pi by 2? Minus pi, which is equal to minus pi by 2. Clear? So this answer is minus pi by 2. This minus sign wave, so minus minus plus. So it becomes pi by 2 with plus this m we have, so we have m divided by n into cos n pi by 2. So now when x is pi by 2 here, so minus minus plus, so it is plus m upon n square into sine n pi by 2. These are the values, and this is the main bracket. So now let us see, can we cancel out anything or not? This is equal to 2 upon pi. Yes, look at here, m upon n square sine n pi by 2, and with this minus sine m upon n square sine n pi by 2. So we can cancel out these two quantities. Now the other quantities, see this, minus m pi upon 2 n cos n by pi 2 minus m pi upon 2 n cos n pi by 2. Clear? So that is minus 2 times m pi upon 2n into cos n pi by 2. Clear? So this term and this term. Now the remaining term is plus sine n pi upon n square. So this can be the value of bn. Please remember the left hand side is bn, right? But let us see what is cos n pi by 2 and sine n pi. If we consider the unit circle x, y, 0, so then this point is 1 0, this is 0 1, this is minus 1 0, and this is 0 minus 1. Now you know that for any particular point x and y, right, the first coordinate represents the value of cos. So this represents the value of cos, and this represents the value of sine. This is theta equal to 0, then pi by 2, then this is 2 pi by 2, which is pi, 3 pi by 2. So let me write, this is theta equal to 0, theta equal to pi by 2, theta is equal to 2 pi by 2, theta is equal to 3 pi by 2, then theta is equal to 4 pi by 2, which is same as 2 pi, which is 0. Then again we have here, this is 5 pi by 2, and this is 6 pi by 2, this is 7 pi by 2, this will be 8 pi by 2, which is same as 4 pi, and likewise. Right, this is 9 pi by 2, 10 pi by 2, 11 pi by 2, and 12 pi by 2. So if you look at the sine and pi are these values, either this or this. So sine and pi is always equal to 0, right? And therefore this is equal to, this 2 and 2 will be cancelled out, this pi and pi will be cancelled out. So this is minus 2m upon n into cos n pi by 2. Now if you want to see that do we have any particular value for cos n pi by 2, right, then which are the values of cos n pi by 2? So when n is equal to 1, then this is 0, then minus 1, then 0, then 1, again 0, again minus 1, 0, 1, right? So the cos n pi by 2 has all these possible values, 1, 0, minus 1, 0, right? And so we are not mentioning here with the particular n. Let us write simply in terms of n, which is n cos n pi by 2. And therefore what is this? Is f of x is equal to summation n equal to 1 to infinity bn, which is minus 2m upon n into cos n pi by 2, right? Can you remember, recall what is our f of x? Our f of x is this, summation n equal to 1 to infinity bn sine nx. So the values of bn is this, multiply by sine nx. If you want to modify this, then we can take the quantity which are independent from n outside of the summation. So 2m summation n is equal to 1 to infinity 1 upon n cos n pi by 2 into sine nx. This is half range Fourier sine series.